Hello everyone, in this video we are going to learn cells in parallel combination. So there are two cells are there having EMF E1 and R1, and second cell E2 and R2. They are connected in parallel. Across the point you can see P and Q is there, 2 points. So one end of this is connected here, other end is connected to Q. One end of this cell is connected to P, another end is connected to Q. So what we can see that current through this is what I1, current through this is what I2. Yes or no? So this is the positive, so current will move like this, and this I1 I2, and current is living at this P is what I. So if you apply KCL at this point P, okay, this point P, so what we can write total current I is equal to what? I1 plus I2. Can we write or not? Yes. So I is equal to what? I1 plus I2. Now what is the potential difference across the cell? Okay, E1. So potential difference across cell E1 is nothing but V is equal to what? E1 minus I1 into R1 by the definition. Okay, generally how we find the V is nothing but V is equal to E minus IR. So I want the potential difference across cell, this cell 1. So that is V is equal to E1 minus current is what? I1 into internal resistance R1. Okay, so bring left hand side, so we can write I1 R1 is equal to E1 minus V. From here what we can write? I1 is equal to what? E1 minus V by R1. Similarly, potential difference across cell 2. Okay, so what we can write in the parallel combination, potential difference is same. So let's say this V1 and V2 both are same, that is equal to V only. So V1 is equal to V2 is equal to V only. So what we can write? V is equal to what? E2 minus I2 into R2. Okay, by the definition. So bring left hand side, I2 R2 is equal to E2 minus V. From here what we can write? I2 is equal to E2 minus V by R2. Now substitute the value of I1 and I2, okay, in this equation. I is equal to I1 plus I2. So use this one. So what we can write? I is equal to I1. This is the value of I1, E1 minus V by R1. And this is the value of I2, that is E2 minus V by R2. And then segregate the term, I is equal to E1 by R1 minus V by R1 plus E2 by R2 minus V by R2. Like write the EMF term together. So I is equal to E1 by R1 plus E2 by R2 minus V by R1 minus V by R2. Or you can just solve this one. Okay, so I is equal to R1 R2 is the LCM. Take the LCM. R1 R2 divided by R1 get cancelled, so you will get R2 into E1, so you will get E1 into R2. Similarly plus E2 into R1 by R1 plus R2 minus V you take out, so 1 by R1 plus 1 by R2. So what we can write? I is equal to E1 R2 plus E2 R1 by R1 plus R2 minus V times of, you can take R1 R2 LCM. So R1 get cancelled, R2 into 1 R2, similarly plus R2 get cancelled, R1 into 1, so R1. Yes or no? Now same I is equal to this expression, right? E2 V1 plus E2 R1 plus E1 R2 by R1 plus R2 minus V times of R1 R2 by R1 into R2. Now this you move to left hand side. So V times of R1 plus R2 by R1 R2 is equal to this minus I. Okay, fine. So E2 R1 plus E1 R2 by R1 into R2 minus I. Now you have to multiply throughout by this term. Okay, R1 R2 by R1 plus R2. If you multiply, so this will get cancelled. Okay, here R1 R2 get cancelled, and here R1 R2 by R1 plus R2 will remain. So what we are finally getting? V is equal to E2 R1 plus E1 R2 by R1 R2 minus I times of R1 R2 by R1 plus R2. Okay, now I want this equivalent cell. Okay, so let's take a equivalent is and R equivalent is there. Potential difference across this side, okay, is what? V is equal to equivalent minus I into R equivalent. So compare this equation 4 and equation 5. So V is there, V is there. So equivalent can we write? E equivalent is equal to this term, right? That is equivalent is what? E2 R1 plus E1 R2 by R1 plus R2. And this is R equivalent. R equivalent is what? R1 plus R2, R1 into R2 by R1 plus R2. So I hope you understood this derivation. Please practice once, like the video, and don't forget to subscribe the channel. Thank you.